Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 3 from the Mechanics M1 International A-Level Edexcel October 2021 paper, telling us about a car which is moving at a constant speed of 25 meters per second along a straight horizontal road. The car is modeled as a particle. At time t equals 0, the car is at point A and the driver sees a road sign 48 meters ahead. Let t seconds be the time that elapses after the car passes A. In a first model, the car is assumed to decelerate uniformly at 6 meters per second squared from A until the car reaches the road sign. Use this first model to find the speed of the car as it reaches the sign. Okay, so just draw a little line here. Let's say this is the point A. At this point, this is where time equals 0. And at this point, this car is moving at a speed of 25 meters per second. And then it starts to decelerate at this point. And the deceleration is uniform deceleration of 6 meters per second squared. So the acceleration is negative 6 meters per second squared. Until the car reaches a sign. Let me call the sign S here. Okay. So we got to find, and the sign is 48 meters away from the beginning of that little bit of journey. So the distance between the part where he starts decelerating and the sign is 48 meters. When he sees the sign, he starts to decelerate. So this is 48 meters. And we need to find the speed at this time by the time it reaches the sign. Okay, so this is all the information we have in this question. Okay, so we have constant acceleration. So whenever you have constant acceleration, you can use the suvat equation, as they're called. Okay, so we can write down the values that we know from the suvat equations. So we know the distance that it's traveled, 48 meters. We know the initial speed, 25 meters per second. The final speed is what we have to find. The acceleration is negative 6 meters per second squared, because it's a deceleration, so it's negative 6 meters per second squared. And the time we don't know. So how can we find V using these equations or using these values? Well, we have a set of suvat equations that you could possibly use. Okay, and one of them we could use is, which involves S, U, V, and A, because we have to find V and we know the others. One of them we could possibly use is V squared equals U squared plus 2AS. That's one possible, way to solve this problem. Okay, so we could, for example, we will have to find V. So this is V squared. It's going to be V squared. U is 25, so this is going to be 25 squared plus 2 times negative 6 times S, which is 48. Okay, so if you calculate this, you're going to have the square root of 25 squared plus 2 times negative 6 times 48. And that will give you the velocity at the time it reaches, okay, meters per second. Okay, that's the velocity here. All right, and that's the speed of the car, so we can say the speed is 7. Why did I say 49? It came out as 7, and I wrote 49. That's weird. Okay, so V equals 7. How strange is that? Because 7 squared is 49, I guess. That's why I was thinking about it squared for some reason. Got to be careful about making silly mistakes like that. Losing marks for no reason. So speed is 7 meters per second. Okay, that's the speed when it reaches the sign, and that's part A. Okay, so now part B. It says the road sign indicates that the speed limit immediately after the sign is 13 meters per second. Okay, so now we're going to have a second model. Let me just a second model. You have A, you have the road sign. You still have the same distance between the road sign and the point A, which is 48 meters. 48 meters. Okay, so 48 meters. It's still going at initial speed of 25 meters per second. All right. So now in the second model, it is assumed to decelerate uniformly at 6 meters per second squared from A until it reaches a speed of 13 meters per second. So, all right, it's going to decelerate until the point before S, because by the time it reaches S with this deceleration, it gets to 7. The car then maintains its speed until it reaches the road sign. So it's going to go for a short while. Okay, it's going to go for a little while before it comes to rest. So it's going to go for a while, and then it's going to come to 13 meters per second. So here, it's going to have acceleration of -6 meters per second squared, and the final velocity in this first section here, okay, is going to be 13 meters per second. All right, and then we want to find the value of t when the car reaches the sign. So then after this, in the second little stretch here, it's going to go at constant speed. So the second little stretch here, it's going to go at constant speed of 13 meters per second. So it's going to start at 13 meters per second, end at 13 meters per second. So therefore the acceleration will be 0 in this section here. Okay, so we're going to find the total time it takes to do this. Okay, so we have to break this into 2 sections, because the suvat equations are only applicable when there's acceleration which is constant. So the acceleration is changing from A to this first point here, okay, and between that point and S. Let me call this the point P. Okay, between A and P, all right, the acceleration is -6. Between P and S, the acceleration is 0. So I can't use the suvat equations between A and S. Between A and P, yes. Between P and S, yes, but not all the way between A and S. So I've got to split it into 2 parts. Okay, so part 1, we can use suvat here and see if we can work out the time from the information given. So we know S is, well, we don't know what S is. Okay, we don't know what the distance is right now. We know U is 25, we know V is 13, we know A is -6, and we got to find the T. Okay, so we can find the T actually, because we know that V equals U plus AT is one of our formulae we can use. Okay, V equals U plus AT. So we can say V minus U over A will be the time. That's a nice easy way to find the time. So the time is going to be 13 minus 25 divided by -6. So that's going to give you minus 12 over -6, which is 2 seconds. Okay, it's in seconds. So the first part, the time is 2 seconds between here and here. Now the second part, here we have basically constant speed. All right, constant speed. So we could say speed equals distance over time, because it's constant speed. Okay, we could even use a suvat if you want to. No problem, we could do that. But U is 13 and V is also 13 and A is 0. Okay, we need to find what T is. Okay, and maybe we could even use the same formula. V equals U plus AT. Okay, so well, the trouble is that won't help us to find the T, because the A is 0, so it will cancel out, so we can't use that. Okay, so we need to find another value, another equation with T in it. Maybe we could use S equals UT, UT plus a half AT squared. But the trouble is we'll have to find what S is. We need to find the distance from there to there. So it seems like, let's see what other equations we could use. We could use V squared equals U squared plus 2AS. We could use, that has to have S in it. It doesn't have a T in it anyway. Let's see, we can say, yeah, S equals VT minus a half AT squared. Okay, again, we have to find T and we don't know what S is. So it seems to me that the only way to solve this problem is to find the distance first. We need to find the distance between P and S first. Okay, so to find the distance between P and S, what we can do is we can find the distance between A and P first and then subtract that from 48. Okay, so that seems to me the most sensible thing to do. Let's do that then. Let's find the distance between A and P. Okay, we're going to find this distance here. We can use that with these values from 1, and now we know the time is 2 seconds. Okay, so now we can use these values and try to find what S is. So for example, we can use V squared equals U squared plus 2AS, for example. We have V, we have U, we have A. We could use this. So we can say we can say V squared, which is 25 squared minus 13 squared over 2 times negative 6 is going to be S. Okay, so just rearranging that, V squared minus U squared over 2A will be S. See what that gives us. So we have fraction 25 squared actually it's the other way around. It's 13 squared, isn't it? It's 13 squared minus 25 squared. Sorry about that. We can see V is 13, so that's 13 squared minus 25 squared. Okay, V is 13 and U is 25. So it's the other way around. It's 13 squared minus 25 squared divided by negative 12. Okay, and that gives us S, which is 38 meters. 38 meters. So I know that this is 38 meters. So therefore, this part here is going to be 10 meters because the total is 48. So I know S is 10. So I can use, the fact that this constant speed. So I can use speed equals distance over time. So time equals distance over speed. So time is equal to 10 over 13. Okay, so the total time, this is like time 1 and time 2 is 10 over 13. So the total time is going to be 2 plus 10 over 13. We can say 2 and 10/13ths of a second. We can leave it like that. You can write it as a fraction, as a decimal if you want, and round it to, 1 second. So we like it as 2 and 10 over 13. Okay, and you can write that as 2.77 seconds if you want. That looks like 135, doesn't it? 2 and 10/13ths of a second, which is 2.77 seconds. Okay, so that's the time taken for it to go from A to S. Okay, so here we had to do, we had to find the distances traveled in the first part to know the distance traveled in the second part, and then we could use that to find the time it took. All right, so there's answer for part B. Okay, now for the third model, the car is assumed to move with constant speed from A until time t equals 0.2. Okay, so now it's at A. Whoops. Let me change the pen. It's at A, time equals 0, going at 25 meters per second. And for 0.2 seconds, whoa, that's a bit big, isn't it? So for 0.2 seconds, that's a bit too small. Something in the middle. Yeah, for 0.2 seconds, it goes with constant speed. Okay, for 0.2 seconds. Okay. The car then decelerates uniformly at 6 meters per second squared again until it reaches a speed of 30 meters per second. So then it's got a similar type of situation to the second situation where it gets to 30 meters per second. Okay, so the V is 13. So in this new situation here, what we can say is, we've got to be careful again because of the different accelerations. Here the acceleration is 0, and here the acceleration is -6 meters per second. So here the final velocity in part A, we can say, or part 1, we can say, is going to be 25 meters per second. And here the initial velocity of 2 is going to be 25 meters per second. And the final velocity 2 is going to be 13 meters per second. The car then maintains this speed until it reaches the sign. So then it continues at 13 meters per second until it reaches the sign. Okay, so there's the sign. So this is like another point. Let's call it, for example, X. Let's call this point Y. So we have three situations, 1, 2, and 3. Now 1 is the time we know is 0.2 seconds. Okay, we've got to find the time at which the car reaches the sign. So from here we've got to find the time. The second situation is identical to the one where, I think part B, it's identical to part B, okay, that it took 2 seconds to reach. It takes 2 seconds to reach a speed of 13 meters per second when you're decelerating at -6 meters per second squared and starting at 25 meters per second. So the time here is going to be 2. This is going to be 2 seconds. Okay, so what we have to work out now, we also know the distance traveled in that time. The distance traveled in that time was, okay, 38 meters. So I can use the 38 meters from here as well. So this distance here is 38 meters in this second section here. Okay, now we know that the total distance all the way across, we know it's going to be from here to there, 48 meters. Okay, and we know the distance from here to here is 38 meters, as we just said. Okay, so we need to find the distance from here to here for us to be able to work out, because it's going to carry on. This is like the initial speed of 3 is 13 meters per second, and the final speed in this third section is also 13 meters per second, because it's continuing that same speed all the way across here. So we need to find the time it takes in this section here. We know that so far it's 2.2 plus this time here. So if we can work out what the distance it is traveled in this little section here, we can work out therefore the time it takes in this section, because we know speed is distance over time when the speed is constant. So we need to find the distance here. Now again, we can use the fact in the first part it's going at a constant speed. So speed is distance over time. Okay, so for the first part here, speed is distance over time. We know the speed is going as 25. We know the distance is traveled is what we want to find, and the time is 0.2. So the distance is traveled in that time is 25 times 0.2. Okay, so it's 25 times 0.2, which is going to be 5 meters. So it's traveled 5 meters here. That's 5 meters. And it's traveled 38 meters. So from here to there, let me just use this. From here to there, it's traveled a total of, okay, 38 plus 5, which is 43 meters. So what's left? It's another 5 meters. Another 5 meters left. Okay, but this time at a speed of 13 meters per second. So in this third section here, we know speed is distance over time, and we want to find time. So time is distance over speed. The distance is 5, and the speed is 13. So 5 over 13. So if we have 2 plus 0.2 plus 5 over 13, that's going to be the total time it takes. So let's work out what that is. 2.2 plus 5 divided by 13, and that gives us 2.58. Let's write it as a fraction first. 168 over 65, and then we can write that as a decimal as 2.58 seconds. 2.58 seconds. So there's the answer to part C. So this whole question is all about suvat equations, basically, right? It's all about suvat equations and how to apply them in this situation. And as I said, there might be multiple ways or multiple formulae you could use to find what you need. I just found what easily came to my head to find the answers, and I hope that was clear. Thank you for watching. Other questions from this paper can be found in the playlist that should appear in this area over here. Other questions from this topic of kinematics and suvat equations can be found in the playlist that should appear in this area. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.